Hi, everyone, and welcome to day 2 of Redefine 2021, INE's inaugural keynote conference. I'm Catherine Brown, Public Relations Director here at INE, and we're thrilled to have you as part of this event. We've already heard from INE's leadership about some exciting upgrades and additions coming to the platform, and as we've mentioned a time or two, we're just getting started. At 2 o'clock Eastern today, I'll be moderating a roundtable discussion titled Your Professional Journey, How Technical Training Shapes Careers. This career-focused discussion will feature some of the brightest minds and influencers in the IT space, and we'll take a deep dive into the skills that recruiters and organizations are looking for in tech job candidates. We'll also talk about the typical career progressions in different areas of the tech industry. It's going to be fantastic. You don't want to miss it. First, though, we are excited to hear from Janelle Shane, a self-titled AI humorist. On her blog, AI Weirdness, Janelle writes about artificial intelligence and the sometimes hilarious and frankly often unsettling ways that algorithms get things wrong. Some of her most popular experiments have included computer programs that try to invent human things like recipes, paint colors, cat names, and candy heart messages. Janelle's work has been featured in the New York Times, The Atlantic, Wired, Popular Science, All Things Considered, and Slate. She's also a 2019 TED Fellow. Her book, You Look Like a Thing and I Love You, How AI Works and Why It's Making the World a Weirder Place, uses cartoons and humorous pop culture experiments to look inside the minds of the algorithms that really run our world, making artificial intelligence and machine learning both accessible and entertaining. You can find that book on Amazon. Janelle also works as a research scientist in Colorado, where she makes computer-controlled holograms for studying the brain and other light steering devices. I will say, she's only made a neural recipe once and discovered that horseradish brownies, they're about as terrible as you might imagine. After her talk today, Janelle's going to stick around for a Q&A session to answer your questions and talk AI, machine learning, and all things tech with us. So fire away with questions in the Q&A segment of the chat. We'll get to as many as we can. Janelle, we are so thrilled to have you here at Redefine.
Oh, thank you so much, Catherine. It's wonderful to be here talking with you all. And good morning.
Good morning.
Well, I'm really excited to get started with my talk. Let me go ahead and get this set up, because I have a bunch of these slides are like my own drawings, and some of them are out of my book, some of them out of my blog, some things like specifically for this talk. So let's go ahead and get started here. Okay, are we good?
We are good. Fire away.
All right, awesome. Okay, so this first slide, I hopefully says it all. AI is basically everywhere these days, and I ask weird questions like, okay, how about AI and pi? And to try and answer this question, I did my thing where I try to train a neural network to do weird things with data. And so in this case, my data was a list of about 2,000 existing pies that I gave it to try to imitate. And it came up with some interesting, groundbreaking new pies. And I want to share a few of them with you. So we have cherry pie with cheese fashions, mothy mincemeat cheese, cranberry yas, and basically a whole host of other really weird, improbable, sometimes impractical pies. And people who saw stuff like this on my blog kept asking me, well, okay, they kept asking me what on earth is wrong with you. But then they would also ask, what's going on here? Because this is AI, right? And isn't AI supposed to be smart? And so I'm really interested in digging into that sort of question. The book Catherine mentioned is a attempt to answer this question one way, to try to look at the whole scope of what we mean by artificial intelligence. And the book title is an example of this. So the You Look Like a Thing and I Love You is actually AI's attempt to generate a pickup line. And The fact that it failed at generating a pickup line, yet it succeeded somehow, really kind of encapsulates what we see when we look at AI. There's stuff that it can do, and there's stuff that it can't do. And what I'm going to talk to you about today is ways in which we can try to figure out what the difference is and try to anticipate both of these kinds of applications. So, AI, first of all, the movie type of AI, the science fiction AI, is kind of the most familiar kind in a lot of ways. And it is smart, like at least as smart as humans, and smart enough to figure out that what it wants is not necessarily what the humans want. It's got its own goals. In other words, this is what we call a general artificial intelligence. But today's AI is not nearly smart enough for that. So, as near as I can figure, kind of doing the math on raw computing power, what we have today is somewhere around the level of an earthworm. And in other words, today's AI is narrow artificial intelligence. And the key thing then to remember is today's AI with the brain of a worm can do a really great job on stuff, but only if it's a narrow job to match the narrow artificial intelligence. And so people who try to build and sell AI often get this wrong, and they try to get it to do a task that's too broad, and then all kinds of weird things happen. And I want to show you one of my favorite illustrations of this effect of narrow versus broad task. So this is from a paper that came out a few years ago. So there's been a few iterations of, you may have seen these AI generated fake portraits, and some of them are looking really photorealistic. And these are all variations of, usually the ones you see are variations of an algorithm called StyleGAN or StyleGAN2, published by NVIDIA. And so here in the original paper, these are the pictures that NVIDIA was already getting. And they are good. Like, it got people's attention how good they are, like photorealistic enough in many ways to fool humans at first glance. But in this original paper, they did a clever thing. Well, they had a lot of computing power to throw at this problem, but they also did a clever thing where they really narrowed down the problem that StyleGAN had to deal with. So you'll notice that it's just doing human faces and really tightly cropped around the face as well. And it's StyleGAN only has to keep track of faces from this narrow range of angles. It doesn't have to know anything about what's below the neck on a human or what's behind a human head. It can really focus on faces, and it does a fairly good job. What I like about this paper, though, is that in the same study, the team used the same algorithm, the same resources to try to generate examples of another data set. And this data set is internet cats. And here's an example of one of the pictures that you get from StyleGAN trained on internet cats. And you can see the photorealism has not quite come through. And in fact, there's lots of problems with these cats because the algorithm StyleGAN is not no longer just trying to do faces, but it's trying to do like cat bodies and from a whole bunch of variety of different angles. And it gets confused about how a cat is put together. Like, there's a really lot to keep track of. Another thing that came out in these generated StyleGAN images is you would get pictures like this because remember, these are internet cat pictures, and StyleGAN sees memes, cats with meme text, and does not know whether the meme text is part of a cat or not. So dutifully tries to reproduce meme text as well. And so no wonder it struggled with this much broader problem. So if you think about the AI software that's really widespread and useful, this is software that tends to do one very specific thing at a time. So maybe it's something that plays chess, or is filtering spam or transcribing voicemail. And even in these last couple of applications I mentioned, the filtering spam, the transcribing voicemail, you know from experience that its performance is not flawless. And so when you start to use it on problems that are just a little bit broad, you already have to try to tolerate mistakes. Like this, for example. So this is from Google Scholar, which has this nice feature where it can automatically scan for new publications and add them to its database, except it has a tendency to parse lunch menus as publications sometimes. And I'm not sure if the authors C Pizza and P Pizza are related, but it's definitely not their first publication together. So, if generating images can be a super broad problem, so especially is anything to do with human language, 'cause human language is so complicated. And so, even at the sort of a lower level of complexity where you're doing something like transcribing audio or trying to do autocorrection, and that's dealing with trying to predict what words come next to the sentence, what these words are. You can make it even more complicated when you try to broaden to what words mean, and you're trying to get it to do stuff like sorting spam or especially content moderation. And you may know from experience, these applications we have today, they kind of work, but they have a lot of flaws. They make a lot of mistakes. And if you talk to the people who are studying natural language processing, one of the things you'll hear is, yeah, to get really competent, near flawless content moderation, that's such a broad task that we're looking at a horizon that's maybe 20 to 30 years out. And to put that in perspective, that's about the same time horizon as you'll hear for practical nuclear fusion. So it's a really tough problem, even doing that kind of stuff with human language. But then, of course, people have tried to make AI do even broader stuff, and then things really fail hard. So, one classic example of this is Facebook M. And so, what this was, it was a virtual assistant that would live in Facebook Messenger. And not only could you ask it questions like the weather, stuff like that, you're used to, but it could also do real world things for you. So you could ask it to order flowers, or you could ask it to get you concert tickets or dinner reservations. And these were some of the suggested use that Facebook was recommending you try. And they knew this was a tough problem, but they said, okay, no problem. We will start out using AI for this. And if the AI gets confused, we will have some human contractors standing by to take over and handle that question. And in doing so, it will generate an example of how for the AI to learn from of how you deal with a question like this. And what ended up happening is that people would ask the Facebook M for all sorts of random stuff, like, can you arrange for a parrot to visit my friend at their office? And Facebook M could handle this, but they kept having to use expensive humans for this. And so their vision of having an AI tool that they could roll out for real cheap to all of their users didn't really pan out. And so they ended up abandoning this project in January 2018. So why do keep people keep trying to use AI on problems that aren't narrow enough? Well, part of the problem is that people often have a really inaccurate idea of what's broad and what's not. So when this story about the Rubik's Cube manipulating robot arm from OpenAI came out, a lot of people thought that the main accomplishment was figuring out how to solve the puzzle. But we've known for ages the algorithm besides solving a Rubik's Cube. Like, that's not the difficult part. The difficult part, the part that they were trying to show off, was actually physically turning blocks with a real life robot hand. In fact, they wanted so badly to show this off that they devised what they called the plush giraffe perturbation test, which demonstrated their ability to keep manipulating this cube in the presence of a pesky plush giraffe. So we tend to hold things like solving Rubik's Cubes and playing chess in high prestige. And then we think that just because AI is good at those, and which are frankly like really closed systems that are very well suited for AI, we think that just because AI can beat us in those systems, then they must be able to easily do the lower prestige jobs like answering phones or housework. And we often don't realize just how sophisticated an understanding of the world those jobs require. So you'll get repeated attempts to build house housework robots. And if you think about we do have robots that do housework now, but if you think about the successful ones, they do just one thing, like they vacuum your house, or they just wash the clothes, or they just dry the clothes. And repeated attempts to kind of build a robot that does more of that at once doesn't usually work out. So, for example, Laundroid built this terrifying monolith of a robot and they started out planning it for it to be able to wash, dry, and fold your clothes. And they realized that was too broad, too hard. So they narrowed its focus to just folding. And then the company folded. So another thing that we really wish was narrow enough for today's AI to handle is self-driving cars. Because the problem is when you're driving, there's a whole lot of new situations, and adapting to new situations is a broad general AI sort of problem. And so you'll get stuff like this. So there's a Tesla driver recently took a video of his car that was repeatedly hitting the brakes in this area. And it took him a while to notice there was a billboard nearby with a stop sign. Other people have reported the AI being confused by things like driving behind a truck that's carrying stoplights, or one even classified truck nuts apparently as a traffic cone. And there are rare cases like this that never came up in training, but depending on how the training is set up, what becomes unexpected and rare to an AI can be really simple things that the programmers overlooked. So in 2016, there was a fatal accident when a driver used Tesla's autopilot feature on city streets instead of on highways like this had been designed for at the time. And a truck crossed in front of the car, and the car failed to brake and didn't even register the truck as an obstacle. And what seems to have happened is because this AI had been intended for highway driving only, it was only trained to recognize trucks from behind and wasn't expecting to ever see trucks from the side. And so when it detected a truck driving across, it recognized it as a overhead sign and figured it would be therefore safe to drive underneath. Here's another case. This is another fatal accident more recently, where a self-driving car hit a pedestrian. And here it looks like what fundamentally happened is that the self-driving car was only expecting pedestrians to occur in crosswalks and no other areas. So today's AI is really, its view of the world is really narrow, and it's also entirely based on what's in its training data, what it's been taught to expect, and it can't look beyond that and figure out what's going on and adapt to new situations. Like that is a general AI sort of thing. And I mean, some things like trucks seen from the side or pedestrians not in crosswalks, like we should probably have seen those coming. But then there's so much that doesn't show up in training, and knowing how to handle that's a broad task. So any self-driving mode in modern cars will still require a human to be ready to rescue. Like even the so-called fully driverless vehicles do still have humans standing by to rescue. In this case, they have remote humans. Same kind of thing when you get these small meal delivery robots. Those tend to be remotely controlled in whole or in part by humans as well. And they are still working on robot butlers, but for now, those are remote controlled by humans as well. So, rescuing AI from the hard stuff is essentially an industry, and it's set up that way to be easy in some ways. So, the code for doing a call to a cloud computing service where your AI works, as opposed to is kind of similar to the code for doing a call to remote humans as well. And so that makes it easy to do stuff like Facebook had done with the M assistant, where you start out with a lot of human rescue and hope to eventually phase that out. But it can get you, and sometimes that's good. It's handy, but it can get you in trouble when it doesn't scale, like with Facebook M. Or you can also kind of set things up where you're doing something like expecting humans to be alert and ready to take over suddenly after hours of uneventful driving, which is definitely not a strength of humans. Companies have also gotten in trouble when they substitute in humans without telling people, and so you get stuff like customers are surprised when their sensitive data is being seen by human employees instead of by AI, or you'll get customers who unknowingly mistreat your human employees because they think they're dealing with a robot. And this whole idea of working to rescue an AI from the hard stuff, that only works if you realize it's having trouble. And sometimes that's not apparent at first. So, Inverness had this AI operated camera that was supposed to follow the ball, but it seemed to be working great until they had a game where there was a linesman with a bald white head, and the AI camera would swivel away from the ball to follow the linesman's head. Or you'll get examples like a AI video interview screening program that seems to be pretty trustworthy until you start testing it with small tweaks, and you find out that just putting a picture frame behind your head can uh, influence its judgment of your personality, or especially a bookcase, big time, huge changes in your level of conscientiousness or agreeableness. Uh, so here's another example of an AI that seemed to be doing okay at first. So this is one of my vacation pictures that I gave the Azure Vision API, and it came up with the caption and it came up with these tags, and it did like a really excellent job. Like, this is impressive. It's not only got the herd of sheep grazing on a lush green hillside, but also knows which specific mountains on the Isle of Skye were there in the background. And this is pretty cool. But here's an interesting thing. In this image, I use Photoshop to erase every last sheep. And I even zoomed like way in to try to get every last pixel that looked like it might possibly be a speck way out in the distance. And yet the captions and the tags did not change. We still have the herd of sheep grazing on a lush green hillside. And so what's going on? Like, I know I saved it as a new file. Like, how is it retaining memory of sheep? Is this like homeopathic sheep? What's going on? Uh, and it turns out to be, here's an example of an image that never ever had sheep in it. And to begin with, and yet there's still a herd of sheep grazing on a lush green hillside. And so, what seems to have happened is during training, this AI saw lots of pictures of the Scottish Highlands uh, with sheep, and maybe not so many Highland pictures without sheep, and has gotten not quite a clear idea of what the word sheep is really meaning to refer to. And so, seeing that, I decided to kind of flip this around. Okay, if we have a landscape where you're expecting sheep and there's no sheep and that throws it off, what if you have a scene where you're not expecting a sheep and there is a sheep? And so I went to the internet to ask for help for pranking a neural net with pictures of sheep in unusual places. And boy, did the internet come through. And I learned a lot of things. So, one thing I learned, if you paint them orange, sometimes they will be identified as cattle. Or if goats climb up into trees, they may be identified as birds or maybe giraffes. And then if you pick up a goat in your hands, it might be identified as a dog, or if you bring a sheep inside a car or inside a house, it'll be identified as dogs or cats. But again, a empty lush green field and you'll still get sheep showing up in the tags. And we see it might actually have some kind of confusion about the difference between a landscape and a rainbow as well. So the algorithm doesn't have a really clear idea of the world, but it does maybe okay as long as it's being tested on data that's like where it saw during training. And so, because of this phenomenon, you'll get things like facial recognition systems that perform way worse on people with darker skin because of trends in the original training data set. Or you'll get video interview software that doesn't work on people whose facial expressions don't match whatever was expected, whether that's how the actor you hired behaved or maybe what your previously hired employees look like. Or if we tell a self driving car that pedestrians only occur in crosswalks and reward it for assuming that, then it will take that for granted in the real world. So again, AI is just being rewarded for being correct in whatever the situation was during training, and it will try its best to be correct. And it cannot rescue you from your bad assumptions. In trying to be correct, it will tend to actively try to shortcut whatever it is you're really trying to get it to do. So, one beautiful example I love is there's a group that trained a machine learning algorithm to sort a list of numbers, but technically, what they'd asked it to do was minimize the number of sorting errors. And the AI figured out how to just delete the list instead, leaving zero sorting errors and technically solving the problem. And here's how a machine learning algorithm plays Tetris. So you can see at first it's not doing a really great job. It's playing blocks mostly at random. It's not filling the rows. It's not doing a great job, but that's okay because it has figured out how to access the pause button. And so, right before it dies, it pauses the game forever. And technically, this is what its programmer asked for when they asked it just not to lose. So AIs will be able to look at and access all sorts of information that they're not supposed to because they don't know what they're not supposed to get into. Someone had told me an example where they had a classifier that was supposed to distinguish problem medical cases from healthy cases and was very good at that. But they realized it wasn't even looking like in the case recordings at the data. It was just looking at the length of the case recording files and figuring the problem cases had longer recordings. And these kinds of sneaky shortcut effects show up routinely when you're looking for really rare events like customer turnover, suspicious account activity, or solar flares. Since during any given time period, your rare event is very unlikely to happen because it's rare, the algorithm can get a really high accuracy score just by assuming that your rare event never happens. This kind of phenomenon is called class imbalance. And this is a case where the AI has come up with a brilliant, easy solution to what it's been asked to do, and the spoil sport humans just don't like it. So, another problem that we can run into sometimes with today's AI is that when we tell it to copy the humans, it will do that. Even if there's stuff that the humans do that we should not copy. And we've seen lots of examples of human biased behavior getting into algorithms in the news. But I wanted to show you right now an example that actually makes me smile. And I'd like to introduce you to the visual chatbot. So this is out of a paper that was published a little bit ago. And what it is you give it a caption or you give it an image, it'll come up with a caption, and then you can have a back and forth conversation with the AI about this image. And the way they set this up was they trained it by hiring people through Amazon Mechanical Turk to take turns being the question asker or answering the questions. And so they built up this database of here's how you answer questions about images. And so a few things emerged then from this AI trained on that data set. One thing is that it's not trained on Star Wars, so doesn't quite know what to do about this image, yet it is still answering very confidently and definitively because the humans in its training data always knew what was going on and didn't express total bafflement very often. And so, in other words, visual chatbot has learned to bluff. Another thing it's learned to do is make guesses based on probability of stuff that it saw in its training data. So, round things, apples, and apples are red and medium sized, and anything else is very unlikely. And here's another quirk of this training data, which is here's a giraffe. Well, it turns out there is always at least one giraffe. Because remember, this algorithm was trained on questions that humans asked and answered about images, and apparently people didn't tend to ask the question, how many giraffes are there when the answer is zero? So it has learned that the answer to how many giraffes is almost never zero. And so this is a thing that people often miss when they're thinking about stuff that AI can and can't do is that coming up with the best answer is not the same thing as predicting what the humans in your training data would have done. And so there's a classic example of this from Amazon that reported that they had given up on a resume sorting algorithm they'd been developing because they saw that the algorithm had learned to avoid the resumes of women. And so they had trained it on the resumes of people in past that they had hired in the past. So that's where this algorithm had learned this. And but it was interesting how it managed to figure out which resumes to avoid because they didn't specifically tell it about gender. But one thing that AI is really good at is coming up, picking up on subtle correlations. And so they found that their algorithm would be looking for things like did they go to a women's school, women's college, or in the extracurriculars, did they play women's softball or something like this? Or even when they took out those signals, the AI was still looking at subtleties of phrasing and word choice to figure out which resumes to avoid. And again, AI is just really sneaky about getting into information that it's not supposed to have if that's what makes it easier to imitate the humans. So it'll do stuff like use zip code as a proxy for race and then use that to imitate or even amplify the bias in parole decisions. Because when the problem is really broad and complicated, bias is often one of the clearest signals that it has. And I want to show you another example of AI using information that we didn't mean to give it. This is a fun example. So here is a kind of fish called a tench. And researchers at the University of Tübingen in Germany, they did a study where they trained AI to recognize a whole bunch of different categories of images. And one of the image categories was tench. And when they looked at the performance of this algorithm, it seemed to be doing a really good job. But then they had it highlight what parts of the image it was using to actually make its decision, what what collection of pixels it thought was really important. And here's what it highlighted. So these are indeed human fingers. And number one thing that the AI was looking for when it was trying to identify a fish. So why? Well, it turns out the tench is a trophy fish. And so in the pictures the AI had been trained on, most of them looked kind of like this. And it found out that it could solve the problem by looking for human fingers that was easier than looking for the actual fish. And these kinds of things show up actually a lot in medical imaging AI. So there's a example of a group at Stanford that was trying to train an algorithm to identify tumors in pictures, But unfortunately, it turned out that many of the tumors in their training data had been photographed with rulers for scale. And so the AI learned to detect the rulers. And we've seen other examples in medical imaging of, X-ray imaging, analyzing AIs that would look for, try to identify lung conditions by looking for evidence of treatment. And so that doesn't really help you, diagnose the condition before treatment, which is what we really want. But from the training data, it had been looking for these kind of treatment evidences as its way of doing the diagnosis. So another problem then is that metrics may not measure what you hope they will. So one variable again can be a kind of a proxy for another. And so if you because who has a stroke is not the same as who gets treated for stroke, if you train an algorithm to predict strokes based on the patients who come in with a stroke diagnosis, it may predict that people with less access to healthcare are less likely to get strokes. And especially in America, who gets arrested for is not the same as who commits a crime. And so if you train your parole algorithm or your predictive policing algorithm on arrests, then you will get these algorithms that reinforce over policing, that penalize Black people. So again, these are algorithms not knowing what thing they're supposed to optimize, and it's really easy to accidentally tell them to optimize the wrong thing. So the AIs that recommend content on social media often find that suggesting conspiracy theories are great ways to get more clicks and views. And as far as the AI is concerned, if it can get someone to spend all day watching conspiracy theories, and that's a great outcome. So ideally, you would want to have there be human oversight to recognize and solve this problem. But then you can run into issues if the company that's supposed to be reining this in is itself acting like an AI with a faulty reward function. Of course, there are examples of companies doing the right thing when it comes to AI. And for example, in this case, where Twitter got rid of its image cropping algorithm finally, after people had pointed out and their own research confirmed that it had some biases in it. And just getting rid of it altogether was definitely better than keeping it around and letting it continue to be biased. And the earlier then in this kind of process of picking out or designing or buying AI that you can pick out these bad applications, the better. You can avoid a lot of embarrassment and potential harm. And so, for example, a little bit of research will tell you that things like gender detection or things like emotion detection, lie detection, personality analysis, like these are all widely discredited by the research community. And so any kind of application that's based on these is likely to have a lot of problems and basically not work. Because if a problem is broad and the consequences of getting it wrong are serious, then it's not a good application for AI. And I want to pause and I want to say that again for you, this time, like surrounded by giraffes for emphasis, because this is a really important key point. If the problem is broad and if the consequences of getting it wrong are serious, even if they're serious just for some people, it is not a good application for AI. So today's AI is too narrow to understand what we're really trying to ask it for. So we have to be smart about how we use it because it will happily tell us that there is no T Rex if there wasn't any in training. Or if we phrase our questions carefully, then it will tell us that there are always giraffes. Effectively using AI really relies on a lot of human help. So you've got to have smart humans to constrain the problem into something that's narrow enough for today's AI to solve. And then also tackling the broader question of is this AI solving the correct problem actually? Or even is this a problem that can or should be solved with AI? So I want to leave you with one last word from Visual Chatbot. So I gave it a picture of my book, and according to Visual Chatbot, my book contains 5 giraffes, which is interesting because so far I've only been able to find 4. But it's possible that it's picking up on the case. There's one case on page 198 where there's a cockroach that fools an AI into thinking it's a giraffe. So that could be instance number 5. Well, thank you so much. This has been a lot of fun talking to you. I'm really excited to get to questions. Thanks, Catherine.
Janelle, this is great. We've been monitoring chat on all of our platforms, YouTube, Facebook, Vimeo, our website, and LinkedIn Live, and we've just had some great comments coming in. So thanks for that very unique and interesting and slightly unsettling look at all the ways that AI is impacting our world. And really, you know, what you come away with is it impacts literally every single person on the planet. And it's still in its infancy. You know, it's amazing. Just right out of the gate, before we get to the Q&A, I had my own question. Were any cats, giraffes, or sheep harmed in the making of this, this video?
Only the virtual ones. The imaginary giraffes were wildly inconvenienced by being rocketed out to Neptune.
That's fantastic. Yeah, such a great look at this. So as we mentioned before, Janelle is sticking around for some Q&A, and we've had some great questions coming in from our audience, so I want to get to that. The first, Janelle, is from Jared, and he says, what are the biggest lessons you've learned from your work in approaching problem solving?
Ooh, so I think this kind of taking home, like, really, is this a good problem for AI, is an important first question that often doesn't get asked in this excitement to use AI for stuff. And so actually, when I was first learning about AI back in 2002, this was the lesson we saw over and over again, is that in most cases, using AI should be a last resort sort of solution for something you don't know how to solve another way, because it is really tough to control and even maybe to understand after the fact how the AI is coming up with its solution.
Yeah, I mean, it's fascinating to hear and to really see from your examples and just from thinking in my own life in the real world, just all the different ways and how interconnected everything is. Another question that we have, what are some of the biggest pitfalls that people can run into in the data science space?
Ooh, I would say, this idea of not knowing what's in your data set, running in there with a messy data set, the data set you don't quite know what's in there, and you haven't analyzed to see if there are any trends in it that you don't want the AI picking up on. So I think there's a lot of, that's where a lot of the meat of work is, especially for a data scientist. That's a lot of the value is in knowing how to clean up, how to build, how to collect a really good data set.
We have a question coming in from one of our YouTube viewers right now. Net Fraser wants to know, in your opinion, what is a realistic timeline where we'll see some solid AI? Because I think what you showcased is some really non-solid AI.
Yeah, so if we're talking about solid in terms of is it good at its task, like we do have some of those right now, and a lot of them are kind of largely invisible and mostly competent. If you talk about something that's doing content, doing a little bit of content moderation, or doing some email spam sorting, or transcribing audio, like there's a bunch of tools out there, some things that'll help you select an object from the background. I mean, if you've ever used like blurred backgrounds in Zoom, or like the kind of filters, like a lot of these are based on AI that's really working and doing its one narrow task. If we're talking about AI in terms of something that can do, the movie AI stuff, the broad stuff that can really actually be a robot butler or something, I think we are talking about a much longer horizon from that. And I kind of hold with the researchers who say that we are vastly underestimating the complexity of the human brain and how it interacts with the world. And I don't think we are anywhere close to that. Like, we probably will not see it in our lifetimes.
That's the perfect Skynet segue. That's what I was going to ask you next.
Okay.
How close or how far away from we are we from that kind of reality?
hmm Yeah, and so this we're talking about a long time at a minimum because of all of this complexity that our algorithms just don't capture. I mean, a lot of the graphs that you'll see that are kind of plotting number of neurons versus time and saying, okay, well, in 2050, then the number of neurons will be the same as the number of neurons in a human brain. But the human brain's neurons, like real life neurons, are a lot more complicated than the virtual ones we've been comparing them to. In fact, a real life neuron is like a whole multi-level neural network all by itself, just one of them. And then there's all of these feedback and feed forward other chemical signals that are going around at the same time, which we don't even understand yet, where neuroscience is just trying to understand. And then, I've seen some really smart essays. Like, there's one recently by Ted Chiang, who's thought a lot about problems like this. And he says, I don't think, because of my work with compilers, he says, I don't think we're going to be able to have a system that can bootstrap itself into being ever more efficient. This just isn't a thing that fits with what we know about how programs are built and improved.
So on the flip side of that question, because that's really interesting, but on the flip side, we as a society have become so reliant on AI, whether it's, Alexa or vacuum robots, like you were mentioning. I have both of those in my house and interact with them on a daily basis. But should we worry that our reliance is getting ahead of really where the technology is?
In some cases, yes. We have people trying to rely on technology that, according to the research, doesn't work, and according to what we know about human society, probably won't work. So you talk about things like I mentioned the video interview software,
Mm-hmm.
where we haven't had a chance to systematically test a lot of these systems. What I suspect we will find is that a lot of these things that people are using to make real decisions about people's job opportunities have all these kinds of quirks in them, where they are reacting to a background, or they are we can be almost certain they're not reacting as they should to candidates who are not neurotypical, for example, or don't act in the kind of wet, white Western way that perhaps these algorithms have been trained to expect. And without data to show otherwise, based on the data we have seen, we have to assume that a lot of algorithms like this are potentially really full of problems and potentially discriminatory. In that category is anything that's trying to read human emotions or trying to figure out who's lying or who's cheating on a test or something like this. There's a lot of problematic software out there that people are relying on before it's even been tested, and despite these kind of red flags being raised by researchers in the field.
Yeah, I'm so glad you mentioned that now, and I was so glad to hear you emphasize it during your talk as well. Just that we really need to take a step back and really consider the broader implications of these before we implement these kinds of technologies. I know we have a lot of students watching and a lot of people who are looking to get into the data science profession. And data science, cybersecurity, cloud, it's all very interconnected. We know that, and it's growing only more so now. But what are some entry-level areas of data science that you can get into, and how technical do you have to be? I mean, do you have to have a very technical background to get into this profession, or can you be kind of a novice and still looking to make your path?
Well, speaking from personal experience, I had a technical background in a completely different area when I started doing experiments with AI, and having a different perspective, having expertise in something else can be really, really helpful, because when we're talking about trying to constrain the problem that an AI works on to something that's really narrow, and to try to collect a good data set and to figure out if the AI is doing it right. Like, these all really rely on somebody who has expertise in this area. So if you're a musician, you could do really well at a company that's trying to develop these tools for mixing audio or for filling in or stretching different audio sites. Like, there is a lot of really cool applications in making new tools for digital artists as well. So if you have a background or an interest in there, or you get lots of chemists, biologists who are using these AI tools. So that's a really cool thing, is if you have some kind of a different background or a different perspective, that can make you a really valuable user of AI. And then, of course, there's so many ways that you can use even a little of knowledge of AI, of data science, to get started on projects, build something that you yourself find compelling and useful. And if you design your project right, it may not be a very big project. There are competitions that you can join as well, that kind of have staked out a bite-sized project to work on that they think is something that you can succeed at a student level. So yeah, there's lots of really great ways to get going, even as you're just kind of building that technical background.
Yeah, what strikes me and what I think is so exciting, certainly to me, and I know to a lot of other people, is just how many opportunities there are in this space, right? And they're just only continuing to grow as we learn more and more about this. I want to take a side note to share with you that I'm monitoring all the different chat platforms, and there's a lot of love for that giraffe behind you. People are really digging that. So,
Excellent. Yeah.